All right. Welcome to Verkle Implementers Call number 11. I have shared the agenda in the chat. This is issue 941 in the PM repo. Starting off with client team updates. Would anyone like to kick things off?
Yeah, I think I can go ahead. So for the Nimbus client, we have been working on the Verkle Trail library, and finally, it's been ready for the past few days, and the testing has been completed. We are computing the root commitment correctly, and we from this week we have started to look into the integration of it into the ETH1 client, and we're talking with the person who was mainly developing the database layer. So yeah, we don't have any perfect estimate till now. Maybe after tomorrow's call we can give an estimate till when we are looking forward to having it fully integrated. And alongside that, we are also working on few optimizations and writing the statelessness part.
Go next. So we did some improvement on the Bezo native side, so we can generate the state root of the Genesis block more faster. Before I think it was 15 seconds, and now it's less than 1 second. So we still have to do some optimization, but it's clearly better. So normally we are able to import the block 12. We did the modification for the gas cost. I'm not totally sure because the guy who is working on that is sick today, so I don't have the final result, but it seems that the last news I had, he was able to import the block 12. So we did some fix. We are also working on the gas cost in order to import more block. And still working on performance, etc. So yeah, we are moving forward. No huge problem for the moment.
Yeah, let me add on the Bezo side where we're going as well. For now, we are not able to produce new blocks. So as Karim said, we're going to be able to follow the chain, the testnet. But for block production, we'll need a bit more of the crypto part ready, and optimizations so that we have some ideas already of known optimizations that are what we get inspired by what people did on Geth. So we have identified 3 or 4 potential optimizations to improve speed. And so this is the things we're going to do next in the next month.
On Ethereum JS side, we are working on house cleaning work, basically getting our current stuff reviewed and merged, and we are waiting for Constantine 3 launch so that we can try stateless executions on that. And in the meantime, we are also looking at how to incorporate the proving library to verify pre-state and post-state.
Yeah, on the Geth side, well, I've been working on the Shadow fork with Perry, and yeah, there are still some issues. I mean, it's a bit frustrating because there's always something going awry, but yeah, like we still made a lot of progress. It's just that we're not quite there yet. But most of the work has been on maintaining or more exactly updating the code base for the testnet. We had some merge issues that we discovered this morning, so we need to fix them. But once this is done, we'll be able to restart the testnet, which is quite important because there were some bugs that effectively are blocking other clients from syncing it. So yeah, we're going to fix this. So Paris said he would be able to relaunch it this week. So it's just up to us to fix all the merge issues we found. Otherwise, Ignacio has been nice enough to work on the replay. We have this replay benchmark that was broken after a rebase, so he started tackling it. But yeah, it's still work in progress as far as I can tell. But it's quite useful because we want to be able to answer some questions that have been asked from us, like what is the average proof size and things like this. Otherwise, I've done a lot of work on updating the specs, so we will be discussing some of those updates today. And I implemented EIP 2935. I also have a couple questions regarding this that I want to discuss here if time permits. And more importantly, we also worked on the transition, like a new proposal for the transition. So it's actually not the conversion, but I will explain all that later during the call. And right, for this week, we have a presentation on ACD next Thursday. So we're going to tackle that. We're going to try to rebase on top of the latest GEF to be able to support Cancun in the future. And right, basically build everything we can to like get as many information from the replay as soon as it's fixed. And yeah, that's pretty much it.
I think I can go next. So from Nethermind side, I implemented the block hash EIP that we discussed last implementers call, but Game pointed out some issues for like when we'll implement it for mainnet. But I think the current implementation works for Cosmian. Except for that, I was just trying to look for performance improvements in the cryptography library and on the client side while generating proofs and basically verifying stateless commitments. So yeah, that's it.
For Aragon, we are waiting for the fixes that Guillaume is proposing for GET. And I've also tried to generate some pre-images through the plain state database in Aragon. It comes out to around 37 gigabytes. So, we had a discussion, me and Guillaume and Andrew from our team, which might seem like a bit longer than expected. We'll resume development on Aragon after GET merges the fixes.
Anyone else with updates?
I can add a quick something on the Ethereum JS side. So we have kind of a smaller sister repo for WASM TypeScript implementation of the Verkle cryptography. So we will be re-implementing Pedersen hash in TypeScript using the underlying Rust compile to WASM that Kev has built. So it used to be that the Rust had Pedersen hash directly. That library has been changed slightly, so that's it's a bit lower level. So we're going to re-implement the higher level Pedersen hash implementation in TypeScript natively.
Yeah, I've made a few changes to the Rust Verkle, and they've been upstreamed to the Bezier native library. There are a couple changes that I think that we'd want to make, like renaming Pedersen hash to be called maybe get true key hash. I noticed the Gef library uses from bytes. I think we want to just get rid of big endian sort of from the API anywhere. It's a bit confusing because in some places we use little endian, in others we use big endian, and mostly just trying to get test vectors across the stack.
Okay. Moving on to agenda item 2, testnet relaunch. Guillaume, I think you had some thoughts you wanted to start with there.
Yeah, and maybe just the announcement. So we're going to relaunch the testnet, like I mentioned during my update. I just wanted to specify. So all the PRs or all the changes we discussed last time are in or should be in as soon as the merge issues are fixed. There's just a couple things I wanted to mention for the update. So except I can't read my what I've wrote anymore. Oh yeah, the gas model is the same. Except that we changed this, so the same as the current state of Kaustinen, except that we are going to not charge gas for the to and from, but that's the next topic. We also not include the Coinbase to the witness if it's zero, like if there are no withdrawals happening, or if there are no fees, like if the block is empty, that it's really empty, you don't have an unchanging Coinbase in the block proof or in the block witness. And my interpretation of EIP 2935 is active, and it's a bit different from the one described. Well, the one that is described in the spec was created for something before Verkle. So we had to, I assume Tanishq also had to get a bit creative for this. In my case, at least, there will be 2 blocks added to the witness, or 2 locations added to the witness. The first one is the location of the block you are interested in, and also the location of the block that is 256 blocks ahead of the current block. And that is necessary because at least necessary in the code base, because because of the way the fork is activated. And in fact, I was going to cover that later in an agenda item, but I guess we can skip the agenda item in that case. So because the fork is activated by a block time and no longer a block number, like what is described in the EIP, we need to find if the block that was 256 values before was also part of that fork. And one way to figure it out without having to read every single block from the blockchain, which is not possible in stateless, is to check if the number for that block, the hash for that block, is present in the contract. Because if it's in the contract storage, then that means at that time that block was activated, and therefore that fork was activated, and therefore we are in the situation where we should read the block hash from the storage. So I think there's a link in the page. There's a link on the Verkle implementers call 11 issue. It's the last link actually. If you want to go look at the discussion, how I updated at least how I ask questions. J11.
Yeah, so basically, if you need to access the block, with regard to whatever the index is, and it does not exist itself in the tree, then that is the direct way to know whether the fork was activated at those particular blocks before or not, right?
Right. So the idea is exactly if you find something, that means the block was activated 256 blocks before. Sorry, the fork was activated 256 blocks before. Sorry, and as a result, you know that you're in a case where you should read the contract. If not, that means, well, in statelessness, that means you have a problem. But if not, you need to be stateful, basically.
But you basically don't need to check for 256, because if, for example, at the index that you are looking for, you don't have the the key present, the data present, then you already know that basically that at that particular index, X blocks before the contract was not activated?
No, because the thing activates 256 blocks after the fork. So you need to know what was the state of the block 256 blocks ago. Finish?
So one other question I have is, so like if we, so right now we are planning to enable this EIP with the Verkle EIP also. So for the first 256 blocks, we'll not have uh, stateless clients. Like if we go with this approach, right?
Yeah, that is correct. Although actually the way it's implemented in my code is just that it will detect that the fork is not activated, but the result will be 0 anyway. Yeah, so that's actually, now come to think of it, this is incorrect. So yeah, it will not be active for the first 250 blocks. You're right. So that's another issue. Yeah.
So can we do something where like for the fourth block, we add all the like last 256 block hashes, and then from then we'll always have the last 256 block hashes from the like block itself. We just have to do once on the fourth block that you add all the last 100, yeah, but 256 blocks, and then we can just move on as like it's already been active, and we'll not have to wait for another 256 blocks.
I would say that's a bit tacky because you have yet another situation where in some case something is enabled and in another case something is not. But if there's no better option, I guess we should do that. Yeah. So okay, I guess we should think that deeper. Might not be active on Kaustinen at first, but yeah, we should fix that for sure. You're right.
But on Caution, I don't think so. We'll need it anyways because we are starting from Genesis.
Yeah, but exactly, it still activates. It will try to read a contract that's empty. So we will say no. The block, the 200, my 256th ancestor is missing, so I cannot use the old system. So I have to read the blockchain, which for a stateful client is not a problem, but for a stateless client is going to be a problem.
But in Caution, like we'll not have any scenario, right, where we will not have the 256 ancestor.
Sorry, we won't have
always. So on Caution, we'll not have this issue where we don't have the block in the database, right? Because we are starting from Genesis. So for every block, we are adding the block hash in the state. So we don't need to do this on Caution.
Right, but my method of checking your 256th ancestor is not going to work in this case. So it will tell me you're missing this block, so you need to go the old method, basically.
No, but that's what I'm saying. Like on Caution, there is no old method. Because from Genesis itself, everything is in state, right? So like we don't have, like there will never be a scenario where we'll have to switch to the old method.
I mean, okay, I don't really want to hog the entire conversation on this. I think we understand the problem. Let's take it offline if you don't mind.
Yeah.
But yeah, that was it for the testnet relaunch. So hopefully this week.
Cool. So next up, we have a topic on gas accounting, schedule changes. Guillaume, I think you had some thoughts there as well. Also, just in the interest of time, maybe we want to try to get through this one and agenda item 4 quickly to get to the transition discussion.
So actually, in my view, this is the most important one,
Sure.
and it's. I mean, yeah, we can. I mean, they're all important to be honest. But my question is, I see Vitalik's not here, but Dankrad is. I'd like to revisit the concept of the gas cost, because I think we're at a point where there's some, at least on my end, there's some confusion. And yeah, what was the point of creating, for example, something like fill cost or all those extra witness cost. My understanding was that it was to limit the growth of the block size, which makes sense. But then we have things like fill cost, which is charged every time the leaf is initialized. So that has
What
nothing.
witness cost first?
So witness cost is everything that is charged for adding values to the witness. So, for example, it's it's defined in the EIP. They're called witness underscore. Well, there's several of them. Witness chunk cost, witness. Try to remember the exact names. But they're called witness underscore branch underscore cost and witness underscore chunk underscore cost. And then there's an extra cost for the write when you create a fill cost, which is the cost you charge. And we're not charging it on Kaustinen, but it's in the spec, so it should be added eventually. And yeah, it's like every time we add a new leaf, we have to charge this cost, but that doesn't grow the witness. So that's what I'm trying to understand. Like, why are we charging this? Is it to limit the? Is the goal to limit the state growth for the block producers? Yeah, trying to make sense really of or at least revisit, because I don't think my understanding of those gas costs is really clear.
No, I see. Okay, I'm looking at this now. With this branch cost, business chunk cost, but there it says it's only charged once per, right? If address subkey is not an access subtree charge, so it's only charged once.
Yes, it's charged upon access, absolutely, but there's the fill cost, which is in EIP 4762. At least the way I understand the spec is that if the leaf was 0 or none, actually it's called, like looking for the exact line, if additionally, if there was no value stored at address subkey leaf key, i.e. the state held none at that position, charge chunk fill cost. So this is the part that is confusing. Well,
If there was,
it's for reference, it's line 246, sorry, 246.
right. I guess this is the cost for adding an additional subtree, right? That's chunk fill cost.
Actually, it just says leaf. If there was no value stored at address subkey leaf key, so it's not about adding the subtree, it's about adding a single value.
I see. Okay, so it's adding a leaf. All right. So it's basically just the cost for like storing a new value, right? In that case,
Sorry, I didn't quite get that.
it's the cost for storing a new value.
Exactly. Yep.
Yeah. Okay. I see.
But so because the EIP doesn't really say the cost for S-store disappears. Actually, I was double checking, and I don't see it being removed. So that's where I'm a bit.
Remove the following.
Yeah, gas cost.
Gas costs, EIP 2200 S-store gas costs.
Right, that's true. There's that. For S-load gas, right, and it's except for S-load gas and S-load gas, right. Charge for change for no change reset. So okay, right. So that's fair. No, it's actually deactivated. That's true. Okay, so that makes sense. And then there's the whole question. Okay, so this is still not great, because in the truncated cost means that in order to charge the cost, you need to go and read the tree. And this means that, I mean, at least in the way I've seen Verkle implemented in Geth and other clients, the tree gets updated at the end. So we don't really hit the tree during EVM execution. And I don't see a way to implement this truncated cost without actually needing to read the tree to see if the value exists.
Right. Yeah, but you do need to read the tree. I mean, whenever you have when you have a read, for example, like you do need to know anyway what the value is to perform the EVM execution, right?
Yeah, that's true. You need to know what the value is, but you don't need to go through the tree. But yeah, I guess that means
it's the same here.
Yeah.
You only need to know whether the value is none.
Yeah, that's true. Okay,
It's
so
just reading the value.
Okay, yeah, you're right. It might be possible to do it. So I have to, yeah, I would have to think about it. Okay, and the second thing I wanted to talk about in this cost thing is I just created an EIP, or actually not an EIP, an update to the EIP. Where is it? Here, so it's pull request 8138. And it's about not charging the to and the from. So this is what I mentioned about the Chalcedonian relaunch. So the problem with this approach is that we still charge when we start a transaction, we still charge 21,000 gas, and it feels that I mean, in the current implementation, at least, on top of that, we need to add the witness cost. But then, what is the meaning of this 21,000 gas if we have to add the witness cost on top of that? My understanding, or at least I think there should be a new interpretation of this 21,000 to say that covers for adding the to and from addresses to the witness. And the reason for this is because, well, first, it breaks a lot of tooling. It makes simple transactions way more expensive in terms of gas, and I, for one, cannot justify this increase in cost.
Yeah, no, I think I agree with that. I think that should be part of it. Yeah, like, I mean, previously we also didn't charge for that as S-store, so yeah, I agree. I think we should just say that the base cost includes those like 3 or 4 reads and writes.
Okay, excellent. And the next question is basically the same thing for call, which is the same thing. Like when you do a call, yes, you add the code, and that should be paid for, especially since you removed the 200 byte per contract code cost. Actually, that's not the same thing, but yes, it still makes sense. But at the same time, you will you still pay a stiff upfront gas cost, and to load the account, the target account. So my advice or my suggestion would be to do exactly the same thing, not include the to, like the target of the call, or sorry, include them in the witness, of course, but not charge for it. So do the same thing for a call, basically.
Right. Yeah, I mean, the difference is going to be quite small, right? Like it's going to Because like depends which code you're loading, right? The code could be somewhere in the middle. It
Yeah.
couldn't be there, so it might not be in the same subtree.
Exactly.
Right. Interesting. Yep. Yeah. Right. What's the cost of a call at the moment?
I don't quite remember, but it's yeah, it's more than the witness cost for sure.
Okay. Right. Yeah, then I think that's fine. Yeah. Yep. In that case, I think yeah.
Okay. Yeah. I mean, I have this PR that I need to complete with the call cost and verify that everything matches, and then I will share it with everybody to make sure that everybody agrees. And if that's the case, then we'll merge it.
Good. Okay.
Cool. Thank you. Yeah, that's all for me.
Okay. Guillaume, do you want to keep going with the next agenda item, the account header question?
The account header question. Sorry, I don't quite remember what we're talking about.
With the first 60%.
Oh, yeah. Good point. Yes. Right. So in the spec, yeah, I should look for the spec. Which one is it? Okay. Yeah. Sorry. Wrong window. But in the spec, it says that the first 64 accounts, sorry, the first 64 slots of an account are going to be in the account header group, or I don't know how to call it, the header group. Right. This is the formula that calculates it. Let me share my screen again. And no, actually, that's the right. So that's the formula. And basically what happened is that if it's below 64, then it is stored in the header group. And if not, it's stored in the main storage. But here, there's the offset is not, like 64 is not subtracted to the storage key. So that means the first 64 slots of the second group, or the first non-header group, are actually unreachable. And I'm fine with that, because that makes things way easier to debug when you're aware of this fact. I just want to know that everybody agrees, and yeah, and this is intended, basically. That was the intended purposes of this approach.
So what do you mean by unreachable?
Right. So you see that function get tree for storage slot here. It gets the address, right, and it gets the storage key, which is just the slot number. And this value could offset minus header storage offset, that's 64. So if your storage key is in the first 64 slots, it will go in the header offset. So you will just add header offset, which is 64, to the storage key. So that's a value between 64 and 128. But if it's above, so it's like index 64 and up, it just gets added to this value. And this value, so that means if you're, for example, you're the 65th slot, so index 64, you will be at index 64 in the group that in the first non-header group, or the so yeah. So that means the first 64 slots are unreachable in that group.
You're talking about the actual storage layout rather than like the EVM doesn't know anything about this, right?
The EVM doesn't know anything about it. It's just the tree.
And like you could subtract header storage offset here, basically.
That's the question,
If you
indeed.
want. Yeah.
We can, yes.
Right.
Should we? That's a different question, but we can, yeah.
Interesting. Okay, if we actually like now looking at this, can this overflow? What if storage key is 2 to the 256 minus 1?
Can this overflow? I would have to double check in the code, but I'm pretty sure not, because then we divide. Yeah, right. Because we divide it, we only take the 31st. Actually, when we get storage key, we get the 31st bytes because the last byte is stored somewhere else. So if you you know, it's this line basically. We do the math in such a way, like we delayed the cast to 256 so that we never have this problem. This is how we fix it. So no, it
Right.
can't overflow.
I see. Okay.
So my suggestion would be to leave it as it is. Just make sure it's documented, because it is quite nice to debug. You know exactly when you look at the witness, you have a correspondence. It's just that it might be confusing. So that's why yeah, it would have to be documented. But just wanted to make sure there's no reason to fix it in a way.
The only drawback is that if you store stuff in storage slots 65, 66, there's like a branch in the tree that is not really, it's like 50% fillable in a way. I'm not sure it's that a huge problem, but for like the gas cost of storing stuff in that branch is actually more expensive because you can only store half of the data that you expect to store, something like that. But I don't know if this is like a big problem or not really. And also if we shift everything by 64, the storage slots will be kind of unaligned corresponding to the place in the tree. I don't know if that will be a problem, but a benefit of how things work now is that everything is aligned. So if you look at storage slot, the storage slot number, you kind of it is kind of aligned to the 256 group in the tree. But yeah, I don't have like a strong opinion, just like mentioning those facts.
Oliver?
Sorry, I didn't quite catch why could it not overflow?
Because it's you only take you see like the address that is highlighted on my screen.
Mm-hmm.
It's a division by 256, so you're doing 31
right.
bit, sorry, 1 byte arithmetic in a 32 byte word, so you're fine.
Okay, got it.
But yeah, Ignacio is right that this might have a gas impact. I still think we should leave it as is, but let's okay, my suggestion is that we leave it as is right now, and if as it always will, the question surfaces again, we can make a decision with better information, because honestly it can go either way, so I'm all for not changing it. Cool, thanks.
Okay. So next up, the transition simplification proposal from you, Guillaume.
Right. Yeah, so actually before that, I hope we still have time, but I wanted to maybe ask the res people if they, because we didn't give them any voice last time. Are you aware of how the proposed overlay transition works, and do you have any comments on that?
We are aware. Initially, we thought that reads would also transition into the Verkle tree, which was like something we discussed internally and we had a lot of issues with because of the way our node is designed. It would be a mess. But I understand after we talked that that is no longer something that is part of the overlay transition method, right? Like
Indeed.
when you read things from the Merkle patricia tree, it isn't automatically transitioned to the Verkle tree. It's only like the fixed increment using the iterator and then writes that go into the Verkle tree.
Yeah, exactly.
Yeah. After that, it seems a lot simpler. So I don't actually think we have any issues with the current proposal. Yeah, it seems doable from a first glance. I've been reading some implementations, like I've been skimming over Geth to try and answer some of the questions I had, and it seems pretty reasonable from what I've seen.
Cool. Well, that's good to know. So yeah, if you have any realization later, yeah, we'd love to hear from that. I think Erigan, I mean, I talked to them as well, but Somnat, do you have any comment as well, or are we still at the point when we discussed last time?
No, I don't have any specific comments.
Okay, cool. So then I can share my screen again. It's screen sharing heavy today. And I would like to propose a simplification for this overlay transition, or at least not the transition itself, but how we approach the delivering of Verkle trees in mainnet. And this is something I did some time ago to explain to my colleagues how the Verkle transition works. Sorry, the overlay transition works. So you have the blockchain here, you have the state of the MPT, and you have the Verkle tree. And so the MPT is frozen, so it remains the same as time progresses. And the Verkle, more and more things get written into it. And at the block finalization, the internal data of the MPT gets deleted because you no longer need it, really, except for sync, but other methods can be used. And then going on to the next slide. So that's I'm just copying the last state of the previous slide. So the data has been deleted. You have an iterator that goes over the leaves of the MPT and just starts copying them. So at the first block, A gets copied, and then the second block, B gets copied, and so on and so on. And well, it goes on until the whole iterator has been as like the whole leaf, all the leaves have been covered, swept by the iterator, and then you just delete the data, and you have a Verkle tree that is converted. Now the new proposal, because this whole conversion is risky and complex and difficult to make work, as I discovered. It's the suggestion would be to have a first fork where we just implement the part on the first slide. So we just start with a fresh tree, but we keep the MPT in the background, and that part where the internal data is deleted, still remains. So once the fork block has finalized, you can delete the internal data of the internal nodes of the Merkle Patricia tree, but you remain indefinitely in that intermediate space where you have two trees. So why do I suggest this? Well, there are several reasons. One of them, so I summarize. Well, there's some reasons not to do it. First, that means you cannot really have proofs in blocks. So that means we delay statelessness. So that's clearly a minus, or at least more exactly, we delay in protocol statelessness. You could still work on having stateless clients that get their proofs somewhere else. And it annihilates all those fancy synchronization methods that especially Tanish worked on. So that's not great, but at the same time, these are the parts of Verkle that are going to take time to implement and are going to delay Verkle. And meanwhile, while we try to get everything right, the MPT keeps growing. So that's why I propose to just do the first part and focus on that. The advantage is that all the clients more or less have the code for that. I mean, they would need to create that same layer that currently exists in Geth, where you have the ability to read first from the Verkle tree and then from the MPT. So there's still some code to be added, but the snap sync will still work. You would need to develop simply update snap sync to also handle Verkle proofs. So it's not like we're not doing any proof, but it's still simpler. And the biggest advantage I see is that at least we stop the growth of the MPT. So while we figure all the fine details of the overlay transition or any other transition, because then maybe the state expiry becomes the best method after all. But yeah, while this happens, we stop the growth of the MPT, which is the biggest problem. And then yeah, we can already delete some of the data. Maybe the sync of the MPT can be left to EIP 4.4, which is also an EIP asking for attention. So maybe it's not a bad idea to do it right after that first Verkle fork. And then we can still work on out of protocol statelessness. Oh, and one thing I wanted to ask, jumping back on that gas question, if we do not create a witness, I guess there's no need to create. I mean, I'd love to hear if I'm wrong, but my understanding is that if we don't add the witnesses immediately, we don't need the gas costs right off the bat to change the gas cost. So that would that would give more support for Verkle, because some feedback that has been given to me was that, yeah, changing the gas cost is what's going to provide the biggest pushback. So at least we get some of the benefits without having the we get some of the benefits of statelessness without having to justify every single gas increase. And the other advantage is because we don't put the proofs in blocks, we don't have to bother the consensus layer to forward those block proofs for us. So yeah, that's basically the proposal. In the issue, like the PM issue, there's a link to the proposal draft that I have here. Let me share it again. It's yeah, it's right here exactly, but you should have access to it so you can comment. And yeah, I see some questions. Oh, it's from Han. How does this new overlay method give an immediate use case to EIP 4.4? Well, EIP 4.4 is about deleting the history and presumably recovering it. So that could actually be a portal network thing. It could be, I'm saying 4.4, but let's say it opens some interest towards those issues, those EIPs, and those concepts that propose to deliver historical state over different channels than the usual sync. That's what I meant. But yeah, getting back to the EIP. So we have like there's a simple description of it, so you can read it, and everybody should be able to comment. So yeah, please do that. And I'm going to, yeah, I think that's it. So if you have questions, I'm happy to answer them. But yeah, that's pretty much everything I wanted to say.
I think there's a question from Oliver in the chat too.
Yeah. How will this affect L2s that require state proofs from L1? I mean, it's basically the same thing as anything that would get proof during the transition, because even if we did the overlay conversion, and for a limited amount of time, like let's say it lasts 2 weeks or 3 weeks or whatever, during those 3 weeks, you need to be able to provide 2 proofs. So the idea would be that you provide 2 sets of proofs, but only if you need to access historical state. If you don't, then only the Verkle proof is enough.
Any other thoughts on this proposal? Are people generally in favor? Seems like, perhaps. Any concerns? Other cons? Yep, Tanish.
But then how long do we wait to actually like enable the gas costs, then enable the proofs, and then we do the transition?
Yeah, that is the question. Probably a year, probably 2 years. Depends. We're going to have to to fight to put that in. But the thing is, if we don't get in right now, I would say it's going to get much harder to handle the conversion. So that's why I would say it doesn't really matter in this respect. Of course, it does matter because you still need to be able to deliver the full product. But yeah, because of this need. Right, because one thing I didn't specify is that because this proposed change is much simpler, we could have other EIPs activated at the same time, namely everything that is in Prague. So we could shoot for Prague. Yes, that would delay Prague by maybe 6 months, but at least it would be there, and the MPT state would stop growing. So yeah, I agree, it's hand wavy, but what I expect is when a lot of core developers, i.e. the guest team, are going to look closer at the whole conversion, there's going to be a lot of pushback that's going to delay everything. So I would rather have this conversation after the MPT has started growing. That's really the core idea behind this proposal.
So and like, would it be too bad if we added like, so okay, I understand the conversion part is bad because that will take time, testing will take time, and it will delay by a lot. But can we not just add gas costs and witnesses? Because I think like adding gas costs and witnesses kind of then provides us with almost all the benefits of stateless clients. Because yeah, right now uh, without that, like without witnesses, we don't get, I think, any benefits of statelessness right now. We'll have to like query like third party for proofs. This way, you can just download the MPT, and I'm assuming that without internal nodes and without all the other things, just the state would be a bit smaller. So if someone just downloads the MPT and they have the witnesses in the block, then they can act as a stateless client.
So I have to disagree on a couple points, but overall I agree that yes, it would be a good idea. I just think it's also going to make things a bit more more complicated and potentially cause this proposal to be pushed back to the next fork, and then the next fork, and then the next fork. But could we add the gas cost? Sure. Could we add the witnesses? I guess. Yeah, like I said, I think it's going to increase the proposal. Where there was something you said I disagreed on. I'm trying to remember, but it was basically you said you have to get proofs from a third party. I don't quite understand that part, because you would just need to. I mean, if you need proofs, yeah, okay, you would get them from some kind of relayer, but that's what you would do in a stateless context as well. So yeah, I'm not sure I understand that point.
So like what I'm trying to say is, like, right now, if we add witnesses, the any client will just receive a block, and then they can verify the block with the data that we have already provided inside the block. If we don't add witnesses, then the client would have to query some other node or a third-party service to get the proofs, and using those proofs, then the client will be able to verify the block.
Right, but currently the blocks are not. Sorry, the proofs are not. Sorry, I'm looking for my word. The proofs are not part of the block, right? They're just writing along. They're not hashed in, so they could be. It's pretty much the same problem, unless I miss your point.
Okay, but we are still receiving the proof with the blocks, right? So like, okay, I think it's just a matter of just one other step, but I think I'll prefer having, like, if it does not delay Verkle by too much, because if we don't add proofs, then we'll have to like work on the healing part of Verkle sync. If we add proofs, we can like spend less time on working on the healing part. So that can be one trade-off. But yeah, like if this like gas cost and witnesses delay this by a lot, then probably we can not do that in one fork.
I mean, yeah, you raise a good point. Oh, sorry, go ahead, Dankran.
Yeah, I mean, I have a couple of comments on this. I think like the first one is, I feel like it's very unlikely that people will agree to a fork that leaves it in an intermediate state that has to be fixed in the future. And the second is that I see a problem. Yeah, like I don't know. I don't really know if it's worth it. Like saying that like we would delay, because like I mean, well, it is like basically the full Verkle tree stuff has to be implemented. So I'm not sure if 6 months is even accurate. It might even be more for Electra. But also like if it's such a long delay, is that trade-off worth it? Because that also delays the full Verkle transition implementation itself again. So I kind of don't see it as being worthy pushing for this.
Well, just to answer some of the points, yes, it will have a huge impact, because the discussion about the conversion is what's going to take most of the time. I mean, I can already tell this is exactly what I'm spending my time doing when I mentioned that to the guest team. Yeah, it's true that we most of it would be there, but the one thing, and that's what I was going to answer Tanishq actually. If you enable like sync is the other big question. Not putting the proofs in the blocks would guarantee that no one tries to solve sync right off the bat. But more exactly, it's okay if people want to get sync to work. It's just delaying the fork to figure out some very smart kind of sync when snap sync already works, basically.
Anyway, but this thing still needs sync, right? Like the new tree that you're creating also needs to be synced, be able to be synced.
Yes.
Right. So sync still has to be figured out.
But so it's just about adapting the existing snap sync to return Verkle proofs. It's not about reconstructing the tree and statelessly executing it, because that is going to set. I mean, Tanishq has already
But
done.
I believe that we had this discussion like 1.5 years ago or so with a lot of people from the guest team, where they were very concerned about SnapSync working with Verkle trees.
Yeah,
Right?
they
Is
were
that solvable?
they were concerned about it. Yeah.
Yeah. But like the problem being that in Verkle trees, all the accounts are spread evenly across the whole tree. And so you would get a lot more dirty trees and potentially never finish syncing.
Was it the argument? I'm trying to remember. Okay, I can. We're over time. I can ping them for that and get back to it. Get back to you on that on the channel.
Right. Yeah.
Dragan?
Yeah, I just want to say that skipping transition seems like skipping few steps, and it probably would be best to be included inside the Verkle. If you skip that transition and leave like 2 branches that ask the question how the SnapSync is going to work, how much data is going to be bigger, and how basically when are we going to do the cleanup. So what I would like to say is it would be cleaner and simpler for the long run to do transition when the Verkle happens.
Yeah, but that's actually just changing the order of something, because you need to figure that out no matter what. So yeah, I don't think that's a good argument, because whether you do it before the first fork or after the first fork, you will have to figure the transition out. So yeah, the crux of the argument is the state keeps growing and we have to stop that.
Yeah, but your argument of not finding solution before implementing something, it's not the greatest.
There are solutions. Sorry, there are solutions. There just need to be they need to be implemented, basically.
Yeah, of course, but your solution basically to not do transition, I meant that, or just delay it in this sense.
Sorry, I missed that. I didn't quite understand.
Basically, what you're proposing is to delay transition. But if we already have solution that we can implement and basically work on, it should be best bet possible to do it right away with Verkle transition. Because if you delay that for months, years, it will basically increase the likelihood that somebody is going to do something bad in that transition time. While if you have transition for 2 weeks, it becomes a lot easier. Time frame is a lot smaller. And potential problem can be a lot less.
Yeah, I agree, but that's precisely why stopping the growth of the state matters, because then we make sure the transition is not longer than 2 weeks.
Even if it is 3 or 4 weeks, 1 month, it's not comparable with year, like 6 months.
William, do you have numbers on state growth? Like, is this your intuition right now, or do we have hard numbers that say right now it's possible and like in 1 year it isn't?
Right, it's not like a clear-cut thing, but currently, so my numbers date from middle of last year, but the estimate, like just continuing extrapolating, would be the state growth was going to be 1 billion leaves middle of 2024. Down.
Okay, that's not relevant. So like what I'm asking is how many percent per year?
Yeah. So
is it 10% per year, 20% per year?
That's so currently it's 800. So that would be 25%. Yeah.
25% per year.
Yeah.
Okay, so 1 year extra gives us 25% extra state.
Right.
So I mean, I think like that doesn't sound like this makes an argument that this is super urgent, just stopping it.
I mean,
Like
Yeah, if it takes 2 years, like some people are claiming, to get everything right, yeah, it's going to start having an impact because that's 50%.
Sure, but also this EAP will also delay it. Sure, like okay, so then it's 3 weeks instead of 2. But in order to like, I think you will not make a convincing argument on ACD, say telling everyone, hey, let's do this. We will be in this weird intermediate state after this hard fork, but we really need to urgently do this. I don't see that argument being very strong right now. If you see what I mean, like it's just like dealing with an extra 50% does feel possible. Like it doesn't feel like, oh, that's suddenly gonna make it impossible. Yes, like I agree that it's getting harder and harder. So that's an argument of doing full Verkle like earlier. But it doesn't feel like an argument that we need to like pull the emergency brake, which is kind of what this proposal feels like.
And I would additionally say that Verkle is priority, so we should have some timeline in year and a half, maybe two, to include it. So it's
And
not
the other
something
thing,
that's going to delay it. Yeah.
Yeah, I think it will also be hard to just like, I think like unless we have the complete story about Verkle, including transition and everything figured out, it will be hard to convince anyone of like starting to do some partial transition to it.
Right. So there is like I insist, we do have a full vision of the transition. We're just trying to split it into. Yeah.
Right.
Gottfried.
Just a little argument here. I mean, one thing that it blocks us also from doing is actually changing anything about how we actually do our hashing and so on. Like the discussion that we had, oh, how do we actually work with all of these 64 bits? Do we actually shift to make everything align? Do we actually want to split our tree into multiple kind of domains? I think we had a discussion with Ignacio last year that maybe we want to sort of defend against these attacks where somebody makes a popular attack deep down the tree, doing a lot of stuff. I mean, it sort of would basically force us to make certain decisions that we have already made, but it would basically make it nigh impossible to actually change certain decisions that we have made for the tree layout. And that's another cost actually that we should actually consider. That right now we could basically say, oh, we actually do minor changes to these kind of things relatively cheaply, and we wouldn't be able to do that later.
Okay, well, I think since we're over, if no one's opposed, maybe we can continue this on the next call and offline. Guillaume, what do you think about that?
Yeah, absolutely. Thank you for feedback. I'll keep thinking about it, and yeah, we let's talk about it on the next call or not, if it doesn't make sense after all. Thanks.
Yeah, we can keep the conversation going offline as well, of course. Okay, awesome. Well, yeah, thank you everyone, and thanks for staying a little bit over. We will see you next time.
Thanks. Bye.
Thanks everyone. Bye.
Bye.
Bye.